And finally, I'm going to end this section with an equation that involves a rational algebraic expression. In general, my recommendation is to multiply both sides by a value that will eliminate the fraction if possible. Um, the other thing that you could do, of course, is go ahead and factor all the numerators and denominators and see if there's anything in common that can be canceled. I will caution you that there is the possibility, we discussed it in class, of extraneous solutions. For example, in this case, I can clearly see that x can be anything except x may not be equal to a positive 2. So if we come along and we get that, that's not a value we're going to include in our solution set. So if I look at this, let's go two ways. Let's go ahead and factor the numerator first. So if I factor this, I've got an x and an x. And factors of 10, right? 10 is 1 times 2 times 5. Factors of 10 that could give me a positive 3. I've got a negative 10 and a positive 3. It would look like a positive 5 and a negative 2. So if I multiply that out, it is the numerator I started with. And that's all over x minus 2, which is fabulous because I do have a common factor of x minus 2 that I can eliminate. So this becomes much more simple to look at, right? You can see all of a sudden now I'm just going to write it as x plus 5 is equal to 7. Super easy, right? X is going to equal just plain old 2. Oh, that's fabulous. Except, remember one of the things we just said, I pulled it off the screen, is that, well, x can't be negative, or positive 2 rather. So although it's a nice solution that came up just in the course of solving it, it's not a valid solution. It's an extraneous solution. So for this particular problem, we have to say that there is no solution because that was the only value that popped up. I said that, one of the techniques I like to use is multiplying both sides by a value so that I eliminate a fraction. And I want to try that here real quick. Let me just get rid of some of this junk. So if I was to think about this problem that way, I could, for example, decide to multiply both sides by the quantity x minus 2. If I did that, my left-hand side would become x squared plus 3x minus 10. And the right-hand side would become 7 times the quantity of x minus 2, which simplifies to 7x minus 14. And I think this does not look, let's see, x squared plus 3x minus 10. If I was to subtract 7x from both sides, for example, this would become x squared minus 4x. And at the same time, if I was to add 14 to both sides, this would become a plus 4. And this now equals 0. Well, if I factor this polynomial, let me move this down here. Is this a little, whoops. No, you just move. There we go. If I factor this becomes, well, actually, it's a perfect square trinomial, right? It's a 2 and a 2, and they're both negative. So I can see I get x minus 2 quantity squared. Well, if that equals 0, the only solution that pops up there is when x is 2. And again, we already said that can't be a solution. So we're still exact same place, no solution.